All right, here is day 2 of our exponent rules. We are starting with this rule that is called power of a quotient. Oh, come on. And this word quotient means you're dividing some things. So you'll see in this first example, the things we're dividing are x cubed over y squared. And that quotient is being raised to a power. The power is this 4. What is going to happen is that all the powers inside get multiplied by that outside power of 4. So this will give me x to the 12 on top and y to the 8 on bottom. In the second example, we have 3 different bases. We have the 3, the a, and the b. The 3 and the a look like they don't have an exponent, but we understand that there's a 1 there. And we're still going to multiply every exponent inside by the exponent on the outside. So that will give me 3 to the 5th, a to the 5th, and then b to the 20. And I'm not going to work too many of these problems. I'm going to leave them for you to try, but I will bring your attention to a couple. Looking at number 7, you could go ahead and start right now, take that outside exponent and multiply all the inside exponents by that. That's not wrong. But the way I'm going to show you, I think, makes it easier. So I'm going to start by simplifying inside the parentheses first using our quotient rule from yesterday, which said find which base has the higher exponent. So in the a case, it's the top, a cubed, and do the subtraction of the exponents there in the numerator. For the b base, there are more b's on bottom, so we're going to leave the b there and do our subtraction down there. And then the base of 10, there's no other 10 on the denominator, so it's going to stay the same. So just doing that math right here, 10 stays the same. There are more a's on top, so I subtract on top. And there are more b's on bottom, so I do that subtraction on the bottom in the denominator. So now this is what I have in the parentheses, and now I'm going to do that third power on the outside. All the exponents inside get multiplied by 3, including the 10, which has an exponent of 1. So this is going to give me 10 cubed, a cubed over b cubed. And then on number 12, I'm not going to work it for you, but I do have a suggested order of what to do that for me is how I would like to do it. I would like to start by simplifying inside the parentheses first. Then, with this power of 4 being raised to the power of 3, I would do our rule from yesterday that says a power raised to a power means you multiply the numbers. So that would be a 12. And then I would take that would now be my outside exponent, and I would multiply it by the inside exponents that I got during step 1. So that's how I would work number 12. Okay, the rest are for you to practice, and you can check your answers with the PDF key in your Google Classroom. On the next page, we have 2 main ideas, and the second one is broken up into 2 sub-ideas. So for the first one on the left, the 0 rule. So the 0 rule says that any number raised to the 0 power is always equal to 1. It simplifies to 1. So here my base is a variable, doesn't matter. Its power is 0, so its answer is 1. Here the base is a number, raised to the 0, always equals 1. On this side, we have 2 different 1 rules about the number 1. The first one says any number raised to the 1 power is always just equal to itself. So if your base is a variable with a power of 1, that's just going to equal the base. If you have a number raised to the power of 1, that's just going to equal the number, the base. And then this rule down here has to do with if the base itself is 1. No matter what exponent you have for a base of 1, your answer simplifies to just 1. So if you have 1 to a variable, that equals 1. If you have 1 to the 25th power, that equals 1. Because what's really happening is you're saying I have 25 ones being multiplied, and it's going to be 1 times 1 times 1 times 1 times 1, 25 times just equals 1. So these rules right here individually are pretty easy to understand. The problem that I see students get is when they're combined all in the same problem, you start to get confused, or you start to think, oh, it can't be that easy, and then you end up complicating it unnecessarily. So let's just look at one with a lot of parts, like number 10. There's 3 pieces that are being multiplied. 1 to the 42 is just 1. Let me tell you what that's not. This is a bad math alert. The most common wrong answer for 1 to the 42 is 42, because students will do 1 times 42, but that does not work, okay? It's just 1. And then times b to the 1, which is just b, times 18 to the 0, which is 1. And 1 times b times 1 is b. And then I'll leave the rest of these for you to try and check your answers in the Google Classroom. And then on the last page, we have the negative rule. Before I talk about these examples right here, I kind of want to set the situation up for you. Let's say that we have a quotient here where there are more x's on bottom than top. Here's what this means in detail. 2x's multiplied on top, 5x's multiplied on bottom. For every pair that's the same top and bottom, it simplifies to 1, because anything divided by itself is equal to 1. These 2x's simplified to 1, but that's it. I don't have any more pairs. So what I have left over in the numerator is 1 times 1, which is 1. And then the bottom I have 3x's multiplied, which is x cubed, okay? So that's a correct way of writing the answer. Here's another correct way. We learned yesterday that when dividing bases, you can subtract the exponents. And when I do that, I get x to the negative 3. Now, both of these answers mean the same thing. They're representing the same situation. The only thing is, in mathematics, we don't leave our answer with a negative exponent. Instead, we take the reciprocal of the base. The base is x over 1, and its reciprocal is 1 over x. And then we change the exponent from negative to positive, or we change its sign. So now you see how those are the same? And so this is the rule that we're going to be working on today. What you'll hear me say a lot of times is, if you have a negative exponent, push it to the other side of the fraction. So in this case, it's in the numerator, so we're going to push it down to the denominator. If I had a situation like this, where the negative exponent was in the denominator, I would just push it to the top and make it positive, and then that would be my answer right there. And that's what these examples are doing up here. You have your basic negative exponent example, where you flip the base and make the exponent positive. You have an example with 2 different bases, so the 2 different bases are the x and the y, but only one has the negative exponent. So that's the only one that gets pushed to the other side of the fraction. So y squared over x to the 5th. Here you have negative exponent in the denominator, so it gets pushed to the other side and made positive, because really y to the 8 is over 1, right? And then in this last example, you do have 2 bases, but they're not different. This time they're the same. And we learned yesterday that when you're multiplying bases that are the same, you can add the exponents. So this can rewrite as x to the negative 1, because negative 4 plus 3 is negative 1. And then now we take the reciprocal and change the exponent to a positive number. And then I only want to talk about 2 examples on this page, 10 and 11. On 10, you could start flipping things around, the x here and this x and this y. And that's not wrong, but my way I think is a little bit simpler, which means less room for mistakes. So what I would do is first notice that these bases match and they're being multiplied. That means I can add their exponents. So -3 and -1 makes -4. And the y's are the same base also, so I can add their exponents. +2, -4 is -2. So now I've simplified everything down to just 2 bases, and now I'm going to start flipping stuff around. Remember that this is really over 1, so when I say flip it to the other side of the fraction, that's what I mean. So x to the -4 flips to the bottom, y to the -2 flips to the bottom. But now that I have nothing left on top, I do need a 1 as a placeholder right there. And then for number 11, because you're dividing the same bases, you could subtract the exponents. But what I like to do instead is take the negative exponents and flip them over to the other side of the fraction. So I'm going to flip m-3 to the bottom and make it positive. And it still has the m. M to the 7 is a positive exponent. You don't have to change it. It stays there. And then n to the 4 stays on top because it's a positive exponent. And n to the -8 moves to the top and becomes positive. So now that I have the same bases here, I can use my product rule, which says when you're multiplying the same base, you add the powers. So n to the 12 over m to the 10. And then do the rest of the problems that I skipped and check your answers in Google Classroom.